everyone. I am Revathi. I am working as Assistant Professor in SNS College of Technology in Department of Artificial Intelligence and Data Science. Today we are going to discuss one of the most interesting topic in database management system, static hashing and dynamic hashing. Let's begin by understanding what hashing is. Ravi, could you start?
Sure. Hashing is a technique used to store and require data quickly using a hashing function.
Good. Now, Priya, can you explain static hashing?
In static hashing, the number of buckets or data blocks in the hash table is fixed. This means when the database grows or shrinks, the number of buckets remain the same. For example, if we have 10 buckets and we use a hash function h of k is equal to 10 mod 10. Then all records are placed in one of those 10 buckets. That sounds simple, but what if too many records go into one bucket? That's called bucket overflow. It happens when multiple keys are hashed to the same bucket. To handle this, we use overflow chains or linked list.
Yes, but overflow chain should slow down the search operations because we need to traverse multiple records linked together, right?
Karan, could you tell us some limitations of static hashing?
Of course, ma'am. First, it doesn't adapt well when data grows or shrinks. Second is performance decreases as more overflow buckets are created. Third one is it may waste space if the number of buckets is too large compared to the data size. So it is not suitable for the dynamic databases where data volume changes frequently.
Exactly. That way we use dynamic hashing, it can grow or shrink dynamically as data changes.
Great point, Anita. Please explain dynamic hashing.
In dynamic hashing, the structure changes size automatically when new records are inserted or deleted. The most popular method is extendable hashing. In this, we maintain directory of pointers to buckets, and this directory can expand or shrink based on data volume. Each bucket has local depth and the directory has global depth, which control how many bits of hashing value are used.
So basically, dynamic hashing avoids overflow problem by swapping buckets when needed. So basically, dynamic hashing avoids overflow problem by splitting buckets when needed.
Exactly. When a bucket overflows, it is split into two and the directory doubles in size if necessary. And when the bucket becomes underutilized after deletion, they can be merged to reduce space.
That's clear. Let's summarize the difference between static hashing and dynamic hashing.
Sure, here's a quick comparison. Before starting hashing, dynamic hashing, bucket size fixed variable. Directory not used in dynamic hashing, it is used. In static hashing, overflow handled by overflow chaining, and in dynamic hashing, sure, here's a quick comparison. Futures of static hashing and dynamic hashing. In static hashing, bucket size are fixed. Variable size in dynamic hashing. In static hashing, directory not used. In dynamic hashing, the directories are used. Overflow in static hashing handled by overflow chaining. In dynamic hashing, handled by bucket splitting. Performance in static hashing degrades with data growth. In dynamic hashing, it is consistent. Space usage in static hashing may waste space. In dynamic hashing, efficient use of space.
In real life, static hashing can be used in small, stable data sets like student record for a particular semester. Dynamic hashing is better for large or growing data sets like transaction system or online databases.
Excellent discussion, everyone. I would like to conclude this topic. Hashing helps us quickly access data. Static hashing is simple but not flexible. In dynamic hashing is more complex but adapts automatically to data changes. So the choice between them depends on whether the database is static or dynamic in nature. Thank you.